Hey everyone, good evening.
Hi, Ankit. How are you?
Hey, hello. Just give me a minute, guys. Cool. Hey everyone. So yes, I hope I'm audible and everyone can see me. So I'll just go ahead and start presenting my screen. Cool. So I hope my screen is visible and System Design 101 is written over there. Cool, cool. Thank you, Srishti. So yes, today we are going to talk about system design. Okay, what system design is and how it can help you. So understand this is going to be like a very high level understanding of system design because as a product manager, I have never came across a situation where I have to go ahead and contribute in the system design. There are people such as engineering managers, CTO, leads, and even your like junior developers, they do not get the chance to go ahead and design the systems. Okay, so it's a like fairly complicated topic, complex topic, which is mostly not left for the product managers. So I'm going to only tell you like a high level concept of it so that you are going to understand if there are some kind of questions that are asked here and there in some of the companies out there. Mostly Google and Amazon are the companies who ask these kind of questions. Otherwise, startups, it is very less probability that if you're not coming from a tech background and people are going to ask these questions. That is rare to happen. But if you come from a tech background, if you have an engineering background, might be some questions might be thrown at you. So this is going to be a high level understanding of what system design is. But before that, tell me in the chat, what do you guys think system design is going to be? Which system and which design are we going to talk about here? So that I understand your expectation.
It's somewhat like design thinking.
Okay. Any other input from anyone?
So what all things are taken into consideration while we are developing any system right from the scratch?
This is good.
Designing the architecture of a platform that interacts with people, and this architecture includes the back end, the front end, the user interface, and all of that.
Right. Correct. So I'll tell you, system design is like very simple. System and design. There is a system out there, and we are trying to design it. Like how do we make sure that the system is usable, the system is functional? So whatever goes design is going ahead and creating something and making sure that you have a blueprint in hand. So system could be anything. It could be a system in your life. It could be a digital system. Right now we are talking about a platform or a digital system, any website or an app out there. So I'm going to tell you how we make sure. So and in this specific context, system design 101, we are going to talk about how does the companies make sure that their systems are scalable, they are able to go ahead and serve the customers at any point of time. Okay, this is what we are going to understand today, and this is like true with most of the systems that you are going to come across in the technical domains. Okay, so this is system design 101. So we are going to talk about two things today. First, we are going to talk about basics of system design, which is caching, sharding, scaling, and load balancing. And then we are going to talk about YouTube system design, which is understanding how YouTube works. Okay, understand, I'm again telling you this, that this is going to be only a high level understanding of what this technology is, so that you are at least aware about most of the terms out there. We would not unfortunately be able to go ahead and go into depth of these kind of things, because that would be beyond. Yes, if you're looking for some kind of content, I can definitely share some content along with the notes so that your guys are able to go ahead and understand what these things are in detail. But understand, as a product manager, you should focus on why and what of the product, not how of the product. We are here getting into how of the product. Okay, so understand your limits, and your best utilization of time is not in understanding like how system design works, but just going ahead and making sure that you are able to understand the user requirement. So at any given point of time, you have two tasks. One is to understand the business or understand the users, and second is to go ahead and, no matter how much aware you are about system design, and second task is to go ahead and contribute in terms of system designing to engineers, always choose the task number one. Okay, so it is going to be very rare that your opinion is going to be taken in these kind of decisions, but this is just for your own understanding. Understand, this is only like a general knowledge session for you. Okay, so there are two kinds of system designs. One is high level system design, and second is low level system design, also termed as HLD and LLD in the labeling world. So high level system design talks about the major components of the system, that on a high level, these are the major components of the systems out there. While when we talk about the specific code, that how this API is written, how this is functioning, what is the function over there, what is the exact kind of database that you have used, what is the SQL query that is running behind the scene, that is known as low level system design. Okay, so I think I have mentioned this incorrectly. This is HLD and this is LLD. Okay, so high level system design, when we talk about the major component, which is, yes, these are going to be so many services which are working together. This is how the data is stored. This is how, these are the most common type of APIs. But when we go ahead and talk about the functional utility of the API, that yes, this is what the API is going to do, and this is how it is going to do, the exact code, then we talk about the low level system designs. Okay, and most of the time you are going to see that architects are the people, or engineering managers or CTOs are the people who are going to decide the HLD of the system, while people who are software developers who are coding there, they are going to define the LLD part. The both of these parts are important in order for a system to work. Then, to give you like some of the differences between HLD and LLD, HLD is simply about how major components are interacting with each other, and it is mostly about understanding business level requirements and converting it to high level solutions. Okay, so you as a product manager can go ahead and go to your CTO or to your engineering manager. You explain the requirement to them, and they will be able to make a plan as in, yes, this is what should happen. They'll not talk about the logic, they'll not talk about the algorithm, but they'll only talk about that, yes, this is the overview of how we can go ahead and do this. Second is low level system design. Low level system design is, it is about the code exact level detail. This is like the exact logic that people have to implement, and this is mostly left to the software developers alone. But as a software, if you are a product manager, only HLD should be enough for you. But if you are a developer out there, both are important for you. Okay, now this is what this is how like any internet based application looks like. Okay, so there is going to be a client, and yes, so there is going to be a client, which could be an app, which could be a website, which could be a chatbot. Okay, then over the internet, it is going to connect with the server. Okay, and when it connects with the server, we are going to find that in the server, there are two parts. Okay, one is the application logic, second is the database logic. So we are going to request it something, and then it is going to make sure that it is working with database in order to find that data out there. Okay, we have understood the example of LinkedIn as in how LinkedIn comments work, how LinkedIn sign up works, as in how the logic layer and the database layer is interacting with each other. And this is also like a form of the three-tier architecture that we have talked about initially, which is client, server, and database. This is the presentation layer. This is going to be the logic layer, and this is going to be simply the DB layer. Okay, so this is how a system works. Okay, and this is one single computer. Okay, but the issue is that the database is mostly the weakest point in the chain. Nikhil, you want to ask something?
Isn't the logic layer would be application logic?
Yes, correct.
Okay.
So database is mostly the weakest point in this chain most of the time. Okay, so what happens is that going ahead and getting data from database and putting data into database, it takes a lot of time. Okay, and when we talk about latency issues, things which are under your control, so understand whenever client is complaining about latency issues, and whenever you're talking about making sure that your system is fast and it is robust, then the weakest layer which is under your control is actually database. There are things which are outside your control, which is like what is the size of the image or things like that, which we are going to discuss later. But here in this system, the weakest layer mostly is the database layer. Okay, that you have to go ahead and send information to the data and get information from the data, and that takes a lot of time because database connection has to be formed. Okay, so now in order to solve this, we introduce the first component which is used in system design, the optimization of this system. Okay, which is a read replica. Okay, so there was one database, one master database, and what was happening was that when we go ahead and put something into a database, or when we go ahead and update the database, like when we are editing the database or adding something to the database gets locked. And for that particular microsecond, it cannot go ahead and take any kind of other request. Okay, and when you are creating a scaled system, you have to make sure that when there is a database which is doing read and which is also doing write, then it is going to be slow. Okay, so what we do is, in order to optimize the database, what we do is we create two parts of this database. Okay, these parts are equal to each other. Like this is just a replica of one particular of the master database. The second one, which is the read replica, also known as read replica, the second copy, it is used for reading. So it is optimized for reading. Okay, there are all the important indexes, all the important optimizations that is important for the application to read the data. While the first one, which is the master database, that is optimized for writing. Okay, so whenever a client is making a request that yes, go ahead and sign up this person on LinkedIn. So whatever information is received from the API, this main data is going to store it. Okay, and within some seconds, it is going to make sure, within microseconds, it is going to make sure that this database is also copied to some read replica database. And then whenever you want to showcase your profile, whenever you want to look at the feed, all that data which you can see in the front is going to be taken from the read replica database. So writing to the main database while getting data from the read replica database. So if there are any kind of issues, as in if read replica is failing, then we also do go ahead and create multiple read replicas as well. So writing happening at one end and reading happening at other end, which makes sure that this is available almost all of the times. Any question in the read and main database right now, so guys?
No.
Okay, cool. Thank you. Yes, so this will improve the latency and performance. Why? Because now your database is actually optimized for these kind of things. It is doing the task that it was supposed to do. So engineers can go ahead and can optimize it for reading by the help of making sure that it is able to like indexing is something that they can do. Maybe optimizing all the rows, that is something that they can do, which will inhibit the data if they were doing inhibit the database, or reduce the performance of the database if they are doing both the task reading and writing from the same database.
So you're basically splitting the database function into two, main database and
Yes. Correct. So database has two functions: adding something or maybe getting something. Okay,
Yeah.
so get things will happen only from one. So it is optimized for that particular thing, while putting into the database is into the main database.
Okay.
So Ankit, one question here.
Yes, Raj.
Yeah, it is also similar concept to this master and slave we use normally in database.
Yes. This is master and slave. Yes,
Okay,
this is
okay.
the terminology is different.
Yeah.
So,
So
but
it's
this
a
is
similar
master.
analogy, right? Okay.
Yes, correct.
Got it.
So understand where everything goes. So and thanks a lot for reminding this, Raj, because this could be a keyword that you might get in the interview. That this database is known as the master database, and this is known as the slave database. Slave database is optimized for reading, while master database is the point of truth, where everything is updated at the latest in the latest snapshot. Cool. Now there is one more problem. Okay, there is one more scenario. Understand that this is the New York Times website. Okay, today if you'll open the website, mostly it might not change. Like for you, it is going to be same, and for someone who is opening it from other point, it is going to be mostly the same. Okay, so this is a scenario where what happens is that I know what the client is going to ask. Okay, so why don't I go ahead and put it in a storage which is much faster than database? Okay, so if I know that database is not going to be faster, and I also know that what client is going to ask, okay, why don't I go ahead and put it into some other space which is much faster than the database? Okay, so then we introduce to something known as cache. Okay, so cache is what we do is imagine like a library. Okay, you imagine like a bookshop. Okay, you have gone to a bookshop, and in that bookshop, what happens is that there are big shelves created. You go ahead and you give a order of the bookshop of a particular book to the person who is sitting at the counter. Okay, who is the shop owner. They will take your money, or maybe they will go ahead and ask the name of the book from you. They will go back to the shelf and they will pick your book and they will return to you. Now the second client will come. They are also asking, for example, a new Harry Potter book is released. And then one person comes, they are going to ask you for that book. You are going to go at the back, pull the book, come back to your seat, give the book to them, and then you are going to complete the billing. Second person is coming, they are again going to ask the same data. Third person is going to ask the same data. So what we'll do is next, you will go ahead and collect 4 or 5 books from the shelf, from the back of the shelf. Then you are going to go ahead and put it on your table. Okay, because now if the next person is coming, you should be, rather than going to the back of the shelf, you should be able to go ahead and give it from the table that is in front of you. So it is going to save you time. You don't have to go back and forth in order to collect the same book, because you know that this book is popular. So this book is going to be like asked a lot of time. Okay, however, you cannot go ahead and put all the books on the table. Why? Because that, like, you cannot go ahead and it is not easy to access these books if you are going ahead and putting all of the books over there. Okay, so this is known as cache. So what we do is, here we have an application logic, and in application logic we are going ahead and there is a main database and there is a read replica, which is true, like we have taken it from the previous slide only. Here we have introduced a new layer of cache. Whenever I be reading any request is happening, the system is first going to check in the cache that yes, if this is available, then I'm going to give you the data. If this is not available, then I'm again going to go to the read replica. Then I'll copy that thing, put it in the cache, and also send it to the application logic. It will make sure that the data is faster. Now the main question. So what is cache? Okay, and how do we make sure that cache could be like one major important component in your system design? So cache is a component, is a software which makes sure that you can access the data faster than traditional databases. Why is it faster? It is faster because rather than calling it in a database or in the secondary memory, the cache is mostly stored in the RAM. I have told you that RAM is the most fastest access memory. So all of the information that you want to store in the cache, that is going to be in the RAM. So it is very fastest to access. But the issue is that RAM is very costly. You cannot go ahead and store everything over there. So you optimize. These are the important things that I have to go ahead and store in the RAM, store in the cache. And that is how you are going to develop your cache strategy. And these are the important things that I'm going to store. These are not the important thing. I'm not going to store them. So for example, if there is a celebrity profile on Twitter, although Twitter is like 100% on cache, they have made sure that they are putting everything on RAM, and then there is a secondary backup on the secondary hard disks out there. But in a practical scenario, what will happen is that if there is a very frequently accessed profile, a celebrity profile, then what Twitter will do is it will go ahead and put all the major profiles which are accessed very frequently in the cache to make sure that the database is not being called and they are putting their latency, keeping their latency to the lowest level. Okay, so it is, but in the real life, it is costlier because you are working on the RAM. Okay, there are two concepts as well. If the data is found in the cache, if application layer is looking for some data and it is able to get the data from the cache, it is known as a cache hit, which means that your latency is going to be very, very low. While if it is a cache miss, as in it is not, it is said that cache, you are not able to find the data and you have to now travel to the database in order to find it. That is known as a cache miss. Some examples of cache are Redis, Memcache, and couple of more are there, but Redis and Memcache are Memcache are most of the one of the famous cache services out there. Yes, any question from anyone about cache?
Can you go back to the previous thing, Ankit? Just the previous. Yeah, 1 second. Okay.
So Ankit, can you please go back to that previous thing? Yeah. So I have one question here. So regarding this master and slave database, so whenever any write operation is performed, so is it something like the entry will be there in both the DB, or it will be in the main DB, then it will get populated to slave? slave DB.
It will be in the main DB, and main and read are replicated to each other. Okay, so they are being like copied every few seconds or something. So it
Okay,
might be
so-
possible that you go ahead and edit your profile on LinkedIn, but instantly you are not able to go ahead and see what changes that you have made. Okay, so it could be like a microsecond or 1 second, depending on the kind of service that you are using.
Okay, so okay, got it.
Yes, Vivek, you have to ask something.
Ankit, on the on the cache bit, so if I'm accessing let's say a website, and if I browse through a certain profile for once,
Mhm.
and the system obviously has a cache miss because I'm accessing for the first time. So now it puts a logic where it puts into the cache, but I may not use it again. But if I keep on, let's say, accessing something which I've never accessed, the whole of my journey will be put into cache. So I'm not able to understand. You said that whole of Twitter is on cache, and you said that cache is a little expensive. How are
Yes,
these
yes,
two
yes.
kind of working together? I mean,
I'll
which
tell you,
one
I'll tell
to add? Because I may not access the same thing again and again. Right? That's the
Correct. So I'll tell you. Okay, so in ideal engineering world, engineers are going to make sure that they are going to optimize for the cache. Okay, because they understand that cache is going to be like a costly thing out there in terms of hardware. Cache is costlier, but Twitter have chosen to do it because for them experience is like the first important thing. Okay, Facebook has not done the same, but Twitter has done the same. It has made sure that everything, like at least till 2017 and 18, when I have last read about that article, they have made sure that everything is available on the cache. But that is not a very good or an intelligent engineering practice. Okay, and what happens is that there are various strategies to keep the cache. Okay, what they will do is you have gone ahead and accessed a particular resource. Now they are going to understand if this resource is going to be accessed further or not. So for example, a celebrity profile, anyways, they find that yes, anyone who has these kind of maybe followers out there, we are going to keep a record of it in the cache itself. Okay, that is the first case. But if it is your profile, they will understand that maybe this guy is visiting right now, but it is not a very frequently used resource, which is known as the least used resource or something. Okay, and they are going to make a policy that no, we do not have to store it, or we have to store it. That is contained in the application logic. So that is a custom logic that everyone has to portray. That does not comes with the cache. Cache is a dumb device. You store something, you are going to get it very quickly. That's it.
one more question though. In terms of the cache, so is it stored on my own RAM or is it stored on the server's storage RAM? Where it is
Yes.
it
So
usually?
that yeah.
If-
So yeah. Please go ahead, Vivek.
Because on my browser, if I access a browser, right, and I guess when I use my phone browser or something, it actually stores the cache data and all of those on my system, right, on my device. But how is that? Because if Twitter is doing that, I'm sure they can't use everybody's RAM and then do it. I'm assuming there's a miss here, right?
Correct. Right. Vivek. So that's the question that I was expecting. Okay. So understand. Cache could be done at both ends. It could be done at your browser, at your client level. It could be done at the system, at the backend level as well. Right now, we are talking about backend. Okay, your browser is very intelligent. When you go ahead and open an image for the first time, website for the first time, it is going to take some time. But next time, it is already saved in the browser, even without the website telling it to do so. Okay, so that happens from the browser. We are not discussing about that right now. We are only discussing about the backend. It happens at the server, that yes, server has to decide for all of these data blocks out there. And the example that I'm giving of Twitter, they've actually used their own RAM at the server in order to store all of the data there.
Understood. Okay.
Yeah. So both are like kind of similar concepts, but here we are only focusing on the system part, which is the server part. Yes, Dhairya, you want to ask something?
Usually we save passwords or some credentials like name or email and address, etc. So those saved things can be considered cache or not?
Yes, username could be stored in some form of cache. Okay, but password cannot be. There is some kind of session data which uses different kind of logic. Okay, so the system has to maintain that yes, this data is not visible for everyone, and also whenever like I have to access this, that is like if in case my system goes down, understand there is one problem with cache. If my system goes off, the like for example the server goes off, okay, and if the cache is not persistent, it is going to go away. Why? Because your RAM is going to become 0. Okay, so they have to make sure that whatever storage they are doing, there is also a replica of the same, and also there is a fallback. So they might or might not store password or usernames in the system, because if their system is gone down, everyone will be logged out and they will store the lose the important data.
Okay, so whenever Facebook like provides one tap login on browser, that is an example of this or not?
Okay, so it depends on how you are using that resource. Okay, so for example, if you are talking about your browser, in your browser they are leaving a cookie. Okay, that cookie is going to be stored in the very fast memory. I'm not sure if it is RAM or something. Okay, but it is going to make sure that that cookie is stored. It is mostly with the browser, and when you are loading the browser out there, it will come in the RAM. So that might happen. I'm not sure about it. Okay, so in that case, it might be possible that yes, Facebook will also go ahead and store some kind of credentials, some footprint of you into their own system. But ideally, no one knows how this has happened. This depends from engineer to engineer.
Okay, so whenever you like, for example, I log in into LinkedIn once. Now I don't have to log in into it again and again whenever I open my browser. So
Yes.
that's the same thing, right?
No, that's not the same thing. This is not cache. This is your local storage that browser is saving and the session that the system is saving. Understand, we are talking about storage. If LinkedIn wants that, yes, this information should be quickly available to the user, there should not be the information that I'm giving. Okay, sorry. So just to recollect the thought, yes. So if your username and password, okay, it is a element to be stored, then Facebook will decide or LinkedIn will decide whether they want to store this data into cache or into the database. They can use it from the cache also, from the database also. If they think there are so many number of users and we might run out of the latency would be higher, then we will go ahead and store in the cache. Otherwise, we will store in the database. For smaller website, it might be stored in the database. For bigger website, they have to decide whether they want to do it with a cache or they want to do it with the database out there.
Okay, got it.
Yeah. Yes,
Just
Gauri, you want
one
to ask something?
question. Yeah, just one question. How do content delivery networks feature here? I mean, how is it related? Is it completely different?
That is
Because they
going
also...
that is going to come in a while. Call.
Okay, fine. Okay. And okay.
Cool. Right. So this was cache out there. Maybe I'll just explain you one more thing in cache.
Ankit, one small question here.
Mhm.
Since you have a read replica, and what if you've updated, let's say, your profile picture, but let's say you go onto my profile and it picks up from the read replica, which I'm assuming is somehow out of sync.
Yes.
And it obviously profile picture is not a big deal, but it could be that in a lot of places the sync has to be immediate, otherwise it could lead to something.
That's what we are now going to discuss. As in, there are so many problems with cache. Okay, so for example, once I have gone ahead and created a cache. Okay, I have created that, yes, this is Ankit Shukla's profile. He has registered that this is their profile, and then it is stored in the cache. Now Ankit Shukla has gone ahead and they have edited their profile. Okay, so how would the cache know if it is edited? Because it is the system, anytime the read request comes, it is going to read from the cache or from the read replica. So how all of this happens? So what will happen is that there are two kinds of policies. Cache expire and cache update. Okay, this is completely different from company to company. Okay, so cache expire is when would you go ahead and expire the cache? Okay, so one strategy would be like we will go ahead and which was the least used resource. For example, the system is going to maintain that yes, this is the list of least used resources. Okay, so as someone was asking a question that if I'm going ahead, logging into my profile, then I'm doing some other journey out there, it is always going to store. So no, it is going to decide from this. This could be one strategy that yes, if this resource is not being used, I'll go ahead and remove it. Okay, they will maintain the data for the same. Second is, it could be oldest resource. Okay, which is first in, first out. Person who would be first in this particular row. For example, if there is a cache element that was very much outdated, or for example, it was in terms of timeline, it was first one to enter the cache. So I'm going to make sure that I'm removing it from the front out there. Okay, so if there is a queue, okay, this person would have, this is the front of the queue and this is back of the queue. This person has entered the cache at the top. So maybe if today, right now we are at 8:30, this person might have entered at 7:30. Okay, this person has entered at 8:30. Okay, so the cache will go ahead, it will remove the first person from the row so that it can go ahead and store everything. And this happens because RAM is limited. We have to optimize it. So some memory would be assigned, and we will make sure that yes, we are utilizing it to the maximum and making sure that we have a policy in order to invalidate the cache. Okay, the second point is cache update. How does the cache updates? Okay, so there is a mechanism for this. Two mechanisms actually. So this is the request. Okay, and this is your main database. Okay, so if anything goes ahead, it updates in the database. Okay, so for example, this is the logic layer. Logic layer has done something that has updated the database. Okay, so now logic will know, as in if edit profile has happened or person has gone ahead and changed their image. Okay, so logic layer will know because it is executing all of these actions. Okay, so logic layer can decide to do one of the two things. Either they can go ahead and whenever this change happens, they can send these changes to cache, plus they can send these to the master database. Okay, and after some period of time, since master and the slave are integrated with each other, it will also, the slave database, it will also get the similar kind of data. Or it can go ahead and just give it to the master database, and master database, over the master database, you are going to run a logic that yes, if these things are changed, please go ahead and invalidate the cache. When you will invalidate the cache, next time, if the person is going to ask for detail in the cache, and if it is invalidated, it is again going to go to the read replica, get the data from here, update in the cache, and then come to the logic as well. Does that make sense? A quick yes or no if you guys are able to
Yes,
understand this.
yes.
Okay, so it can happen from the database ends where you will put like an automated thing out there which will understand that yes, these are the things that are stored. Are they latest or not? Or whenever you are making that change, you will make sure that yes, there was a profile object, there was a user profile object stored in the cache. Okay, so we will go ahead and understand that yes, we will the logic layer will say that yes, if this change is there, this the cache might have a outdated version. So I'll go ahead and make sure that I'm informing the cache that go ahead and store this and remove the initial part. Okay, and just to conclude, cache happens at all of the points. Okay. So if we talk about browser, okay, cache, there is a cache at the browser end as well. Okay, so you can go ahead and if you try to like access the same website again, you will see that it is loading faster and faster. Server can also control this. Server sends a file to the browser which tells it whether to go ahead and use their cache or not. Okay, so it can be controlled by server, but mostly these days browsers are intelligent enough to do this task. Second is the cache is in the server. Okay, which we have just talked about. Okay, so in server, there are two examples. One is Redis and second is the Memcache. Okay, also there are third kind of players known as Netflix. They have gone to the next level. They have gone ahead and put it in the network as well. So what happens is that the Netflix, I'm not sure if it is true right now, but this data is from like 2019 or so. So what they used to do is they at most of the network location, most of the ISPs out there in the US, they used to keep a box where they would store the cache of latest movies out there, which will make sure that the latency of people is very, very low. I'll share an article with you where all of these things like about this particular box is mentioned and how how Netflix has gone ahead and over optimized for their delivery. And when we scale this, like this particular thing of Netflix into bigger things, we will come across something known as CDN, which we are going to discuss in a bit. Cool. So this was cache, but cache is like a very important concept. Most of the time when people have to go ahead and optimize their website, they will go ahead and put a cache on the top of it, and although like the reliability in the database is going to get reduced. Now we have done this. We are here. We have a server. There is an application logic. Whenever a write request is coming, I will go ahead and put it in the database. And when I put it in the database, I'll also make sure that the read replica will be done automatically from the file system, while the main database will make sure that the same application logic will make sure that the updated cache is also updated. Okay, so this is like a happy condition out there. Can anyone tell me what is the issue with this? Like, what are the issues that you can see with this particular thing? What issues can crop up when you talk about a bigger service such as YouTube or something else?
Then for YouTube, there will be too much of cache required there because the size of the videos is very large.
Yeah, so database, the movies, I would say the videos, mostly they are not going to go ahead and store in this particular part. Okay, so yes, I'll tell you that issue is when you go ahead and go at that particular scale. Okay, the major problem of all the resources will happen. You will not have enough RAM, you will not have enough processing power. Okay, because one computer can only give to a particular action. So we have discussed about a concept known as horizontal scaling and vertical scaling. Here we are only talking about vertical scaling. Okay, this is one computer. You can increase its RAM to a particular extent, right? So now what you will do is we'll go to the next module, which is we will do the horizontal scaling. We will add more of such servers in order to make sure that everyone is happy, everyone is able to go ahead, the service is able to go ahead and give the request to address the request of so many people out there, no matter how many people are using the website out there. Okay, so you will go ahead and create the replicas of these servers in order to make sure that if one server is busy, other server should be able to go ahead and take the request. Okay, now here also you will need something in order to do all of this. It will not, magic will not happen. Okay, so we have a new software here which is known as load balancer. The load balancer will work in this way, that here the client will make the request will come to the load balancer. Okay, and when the load balancer is, so load balancer is just a piece of software. Okay, here it will come to the load balancer, and then the load balancer will make sure that it is redirecting it to the particular whatever the server is available at that point of time. How does the load balancer decides where to go? There are multiple logics. One logic could be it will understand who is free at this period of time. It will understand who is like whose resources are less constrained. Okay, third, it will maybe can do a round robin, as in, yes, first request I'll send to server 1, second request I'll give to server 2, and third request I'll go to server 3, and fourth request I'll give to server number 1. Okay, so load balancer is a concept. Load balancer is a software which makes sure that you are able to create a distributed architecture. This, what you are seeing in the screen, is known as a distributed architecture, where you go ahead and replicate your system, your application onto multiple computers, and they are syncing with each other with the help of load balancer. For the world, this load balancer is your computer, but load balancer understands that yes, I have to go ahead and send this request or get the response from the particular server and send it to the right kind of client. So it has to maintain who is calling it and from where the particular request is coming, and also where the response should go. Okay, now
So in this case,
Yes, Siddharth.
yeah. So in this case, the response from all the servers would be if they are going in parallel. Will that affect anything? I mean, this request we are dividing into different servers, right? But while receiving the response, would that affect?
It depends. Yeah, I'll tell you. It depends on the bandwidth that you have taken. That's the first part. And second is it depends on the kind of request. Okay, so for example, if we talk about YouTube, okay, if this person is trying to go ahead and access YouTube, then what will happen is that YouTube does not care where the request is coming from. Okay, they will see that if this server is free, I will go ahead and make sure that the request is going ahead and from any particular server out there. Okay, if it is contains, but if if there are session data maintained, for example, if it will come to this server request, okay, and now the server session data is maintained over here, then it has to make sure that load balancer for all the recurring requests from the same user, it has to only use this particular server. Okay, so it depends. It actually is contained in the load balancer logic. Should I go ahead and can I use a different computer for every request from the same user, or there is some logic to it? But bandwidth shouldn't be an issue, like, because these days people are using cloud.
Yeah, so Ankit, I have a question here. So you mentioned about it if session is maintained here in case of YouTube. But in case of YouTube or rather than say any Google site, session is always maintained only. They never forces us to log out.
Correct. So Shivam, we are going to talk about in a bit.
Okay.
Cool. So now one problem occurs, okay, which is we have gone ahead, okay, we have replicated this data. There is server 1, there is server 2, there is server 3. Okay, some person has gone ahead and they have logged in the website, and now they are going to go ahead and make sure that they are able to like consume the server and do whatever the task that they have. Okay, now one issue will come. The issue is that this particular database that you are storing, okay, although the code, the application logic, it cannot go beyond GBs, okay, because that is code, that is algorithm. But that is just instructions and programs, okay. But this database, it can go ahead and go to any particular extent. If you talk about like Google, if you talk about YouTube, if you talk about Facebook, their databases would be in like multiple terabytes out there. Okay, on the scale of hundreds of terabytes out there. So how will we make sure that if this particular part, main database and replica database, if they are still a part of one computer, then how do we make sure that we are able to scale this computer to terabytes? That is not possible. So what we are going to do is we have to go ahead and take these things out. Okay, we will go ahead in the next session, in the next iteration, we are going to take the database out of the 3 computers. Okay, and this is one database which is connected out there. But the issue is that if we go ahead and how do we go ahead and this particular database, it is also going to face the same problem, which is one computer is limited by its resources. How do we make sure that this is also scalable? So in the next part, we will go ahead and break the database. Okay. Now one problem will occur if we have gone ahead and broken the database. And for example, if this person has came and they have been accessed by server number 1. For example, you have logged into Google and Google is giving you from this particular server. And this particular server, initially they were going ahead and taking a database from here. Their database is, for example, this. So how would they know that now they have to change the database? Okay, so now in the initial session about SQL or about NoSQL, I have told you that there is an issue with SQL that they cannot go ahead and by logic, they cannot go ahead and scale horizontally. So what we do is we go ahead and break the database, but we have to make sure that all of the databases are accessible by all of the servers out there. So as Shivam has asked that if Google, for example, one request is taken by server 1, and now if the other request is taken by server 2, then that does not mean that Google should go ahead and log you out. So Google should always have this particular thing. But if one application is connected to only one database, how is that going to happen? Are you guys understanding it? A quick yes or no in the chat.
Can you repeat that last part, Ankit? I don't think I followed.
Yes. So what is happening is that if you go ahead and if one server can only talk to one database, okay, then what will happen is that if Shivam has logged in,
Yeah, I got
and
it.
their first request is taken from server number 1. Now server number 1, other people have also logged into server number 1. Okay, now
Yeah,
it is
got it.
choked. Now Shivam again wants to go ahead and go to page number 2. So their login data should be maintained, right? But if that login data is only with database number 1, then they will suffer. Okay,
Yeah.
like their session will log out and all. Okay, so now we also need one more thing, which is this database should also work in synchronization with each other so that all of these 3 people are able to talk it with it at a particular point of time. So it should be regardless that if this is logging, that is logging, it should be regardless of the person who is logging or regardless of the context, everyone should be able to access a common database.
But here also you would need a load balancer, right?
No, there is another thing that we are going to throw at you. Okay, so now we are going to introduce a new concept,
One
which is
quick
known as
question, Ankit. You initially mentioned, Vivek, that the system takes care that since it's the same client accessing, the same server is invoked so that the logic is kind of used. You did mention that. I'm guessing because of the database constraint in the
In the initial you were mentioning, in the initial calls?
Where the database was there with each of the servers. So there was server 1, 2, 3. The database was there with each of these. So on the previous example,
Yes.
yeah, in this,
Yeah,
you
this one.
mentioned that. But now that the database is actually shared, does that request need to come to the same server? It can go to any server, right? Because the application logic
Yes,
will
yes,
remain
yes,
constant.
yes, correct. So application logic
Okay.
is different. Okay. Now, but this can take infinite amount of memory, this database. Okay. So we need to keep it. First of all, we need to decouple it from this particular system. And we also have to make sure that it is also a part of a distributed system because it can take any amount of memory.
I think it
Got
will be the auto scaling will come into play here.
Why should
your
it be
question answered, Vivek?
decoupled?
Yeah, Ankit, answer.
Yes. It should be decoupled because can anyone tell me why it should be decoupled? Why should these databases should be decoupled from the server?
It's not scalable like this, right?
Yes.
I can also see
Cool.
one more issue, Ankit. If you
Mhm.
put the database in one server, then if I'm accessing my data or I'm putting something to my, let's say, my profile, and it goes into the database with the server 1, I always have to access server 1 because I'm not sure if server 2 also has the same data or not.
That replica that can happen. Maybe we'll again set up a replica
Okay.
over here.
Okay.
Right? Yes.
Okay.
Cool. So now, but understand here with the load balancer, we have gone ahead and created like one system into like a distributed system. Okay, a monolith system into a distributed system out there. Okay, but database contains like logic. Like application code, you can go ahead and replicate as much as possible, but data actually contains data. So you have to make sure that whenever you are breaking this data, there has to be some kind of logic. That logic is known as sharding. Sharding is you go ahead and break your data into something. Okay, for example, there are 1 million rows in your database. You are going to make 2 parts. One is 1 to 500 and second is from 501 to maybe 1,000 million. Okay, maybe 1 billion. Okay, now there has to be a logic, there has to be a layer which will say that yes, if any server 1 says that I want this data, so there has to be a logic which will tell us, which will help the application layer find that yes, if you're looking for row number 400 million, then this is the shard that you should go to, and this is the shard that you should not go to. Okay, so that logic is actually contained in sharding application logic. So sharding is actually a kind of load balancer, but it contains a more matured logic about SQL. And this has to be custom defined. Like it is not that you can auto scaling, like for load balancer, you can go ahead and there is like a out of the box solution. You can go ahead and put this software. It is going to make sure that whatever is the available server, I'm going to use it. But sharding, it depends from company to company. If my company has a customer database, where do I need to break it? What is the IDs that I need to consider in first shard? What IDs do I need to consider in the second shard? And that is how it happened. That is why I was saying in the SQL session that it is not very easy. You have to work in order to go ahead and make your SQL scalable. But right now, these days, people are also going ahead and making it a simpler thing as well. Okay, so this is a sharding application logic. What sharding will do is we have one particular row. Okay, we have one particular table out there which contains all of these things. So what sharding will do is it will make it into 2 shards. This is 1 and this is 2. And this sharding will contain this. Yes, if you're looking for this table in this row, it would be there. If you're looking for this table in this row, it would be there. Go ahead and find it from there. So that no matter where you are accessing it from, you will get the data and still the platform is very scalable. Okay, so just to capture everything again.
So
Initially-
sharding just maps the data where it's located.
Yes, correct. And since it is custom to every company, it's like going ahead and you cannot say that how Facebook is doing it, Instagram can do in the same way. That's why it's a different concept than load balancing.
So it is also relatable to this hash table thing?
Yes, correct. So hash table is related to this load balancer as well. It is related to the particular this sharding as well. So that's the logic that most of the people use hash tables in order to go ahead and distribute the loads and understand which machine to send the content to. Yes, Pretty has a question, but still the database is no, it is not. Okay, so what we have done is we had one database, okay, of maybe 100 million rows. We have broken it down. Okay, we have broken it down into two parts, which is this is 50 million and this is 50 million. This is two systems now, two different computers. Okay, and now these computers are going to talk with each other through the help of a sharding logic. And this sharding logic is again code. That's it. So for understanding, for building the logic for this particular like a combination of 50 million and 50 million rows, the logic could be very simple, that if it is from 1 to 500, go to shard 1. If it is from 501 to 1000, just go to shard number 2.
So Ankit, is sharding possible in both NoSQL and SQL database, or is it only for SQL?
No, that is possible. So understand, SQL data, the NoSQL database are actually optimized version of actual database. Okay, so for example, I have told you that there is a key value pair store, right?
Yeah.
So here also it might happen that if you have broken down the both of, like if you want to go ahead and there will be a limit where you can store as many keys and values, right, in a particular system. So you have to break it down from somewhere, and then you can again put the sharding logic over there. But it would be simpler than the SQL one.
Okay, got it.
Cool. So Pretty, were you able to understand this?
Yes, Ankit.
Okay.
So, but one question, when you say database is divided, so my question is, I understand the sharding will happen, and then the database will logic written, then, and according to logic, the table will be divided. But these tables, all this database is still in the one particular machine or server?
No. So what will
right?
happen is, So what will happen is that you are running a server, okay, and now your developer operations person, he has understood that, boss, the limit is maybe 5 GB, and we are now at 2 GB. We are now at maybe 4.5 GB. So we'll have to do the sharding. So they will execute the logic and break this 4.5 GB into two systems. Okay, one will remain maybe 2.5 GB, and other will be, they will take another server where they will keep on storing the new data out there. Okay, so there would be like a something trigger that will happen, that yes, now we have to go ahead and do the sharding out there. Some people do it on auto mode. Some people wait for this trigger for it to happen.
Okay, got it. Thanks.
Correct. Cool. So a quick recap. What are the concepts that we have talked about? First, we talked about the master and slave. Why? Because we can optimize the database for reading, and then we can optimize the data for writing. So that if the purpose is different, we can optimize it and make sure that the latency is lowered. But the issue with that is that there could be some kind of delay in data. Okay, so availability could be like a issue for some time. As in, we go ahead, I have just edited my profile. The profile edited details are in the master database, and master database and slave database take a couple of seconds to couple. But whenever I'm going ahead and going to my profile right now after making the change, I might not be able to see the change. Okay, so if you want to experience this, go ahead and write something on LinkedIn, and at the same moment, go to your profile. On the first page, you are not going to see that you have posted something, because the profile page that is coming from the read replica, while when you go ahead and post something from the home page, that is going initially to the write replica, the master database, not replica. Okay, so this was first optimization that we have done. Second optimization was cache. Okay, if we can save read from cache also, from the database also, why don't we go ahead and do this? Okay, and cache, but it has some kind of limitation that it is stored in the RAM, so it is costly. And you always have to make sure that you are able to update the cache whenever things have happened. Otherwise, your system will become outdated. Okay. The third part that we talk about is horizontal scaling. How does horizontal scaling take place? It takes place because of something known as load balancer. Load balancer is something that enables the horizontal scaling. And then fourth, we talk about sharding. Sharding is for distributing databases. Okay, so 4 concepts in this, and most of the times these concepts would be enough for you to go ahead and like create a fairly robust system with all the non-functional requirements at place. Now quickly tell me everyone, on a scale of 1 to 5, how well are you able to understand these things? Cool. Now, so we'll now quickly introduce you to a very simple concept of CDNs. Okay, so we have talked about latency, that database, this happens in database, we are going to put the cache, but actually the major bottleneck is from the client end. Yeah, so from the client end, the major roadblock is not your database. It is actually the storage. It takes time for them to go ahead and get the video, get the files that you are going to send them, maybe the JS or CSS files, or also the images that your media that you are going to send to them. Okay, so how do you make sure that this data is also available to them at the right point of time? Okay, how you can reduce the latency from there as well. So what happens is that the problem is that the database is the files that you want to get from that particular website is stored in maybe a server which is maybe in the US. You are accessing it from India. So what a CDN does is CDN will make sure that when you are accessing it, it will give you a replica of it that is coming from maybe Mumbai, that is coming from maybe Delhi, which is much more near to you. So CDN is nothing, it is a content distribution network where we go ahead and make sure that the replica of major files of that particular server is divided across the globe. Okay, so for example, this is the origin server, which is in the US, and someone is accessing it from US, someone accessing from Brazil, someone accessing from UK, someone is doing it from Singapore. Okay, so when they are accessing it, the data is always going to come from the US server. Okay, but in this case, when we go ahead and introduce a CDN, it makes sure that we are going ahead and replicating this particular content, the main important content that is images and data out there, that will be coming from a local storage out there. Okay, so that the latency is reduced. You do not have to do a round trip from the US to India in terms of the wires out there, and you get the data as soon as possible. Very simple concept, and two major players in this market is CloudFront, which is from Amazon, and Cloudflare, which is an independent company.
So is it because of the internet cables which are underneath the sea? So if you are getting the data from US, it takes more time for us to, in simple terms, for us to
Yes.
for it to reach us.
Yes, correct. Although it travels with the speed of light, but still,
Yeah,
why don't we go ahead and save some microseconds, right?
and it would be cheaper also.
Yes. Yes, Gauri, you want to tell me
Is
something?
this for only heavy content, like for?
No. These days,
heavy content?
no. These days, even the smallest website, even at the Hello PM website, we have used CloudFront to make sure. Even we have like most of the users from India, still we go ahead and use it because it is very cheaper, like almost no cost.
Okay, and what is POP?
What is that?
Pop-
I'm not
Pop
sure.
one.
I'm not sure what they have mentioned about this.
Okay, POP 1, POP 2. This are they
Not sure.
servers?
Not sure.
Maybe
No,
I
these
think it is population according to the geography. Seems like pop.
Not sure. We can just go ahead and search
Are
it. Right?
they servers or
POP,
something?
CDN. These are storage servers. CDN POP locations, points of presence. This is known as points of
Oh,
presence.
okay.
Okay.
They're basically storage servers.
Yes, correct. So understand, the code can also be stored over there. There are many companies who put their code on a particular kind of server also there. Okay, but that is beyond our understanding. Like that is beyond our level of going ahead and explaining over there. So only you don't have to go ahead and make sure that you can definitely store all the only media on these servers, but you can also go ahead and make sure that code is also there. So one of your load balancer can connect to a server which is in this particular place, or maybe there could be multiple load balancers out there. But that is beyond our scope. Cool. So yes.
1 second, you're saying that they put logic in the original server.
Okay, so understand that I talked about that load balancer if there is a code present somewhere. Okay, so for example, there are two kinds of systems that we have. One is the storage system, which
Mhm.
is databases, your file storage, your object
Yeah, yeah.
storage. Second is application layer. Okay.
Okay.
The real meaning when CDNs were created, they were created to make sure that the heavy data which is in the storage should be given by the CDN, while logic will
Mm.
happen from the main server itself. But these days it is even possible that yes, whatever I have told you, that there is a load balancer and there are 5 servers behind a particular load balancer. Okay, so one of those servers could be nearby you as well.
Okay, fine. Okay.
So application logic could also be contained in the in some kind of CDNs.
Okay. Okay.
Cool. So now we'll talk about that one simple concept of function and non-functional requirements. Okay, so understand, I talked about here whatever we system design that we are doing it for the non-functional requirement. What is non-functional requirement? Which is that does not have to do anything with what the user is looking for. User will not tell you these kind of things. Okay, so for example, if we talk about YouTube, so if I tell you, how would you go ahead and improve YouTube? Okay, so what you will say, maybe we'll go ahead and introduce a like button. We will make sure that the spamming algorithm is improved and these kind of things. Okay, but as an engineer, you also have to take care of some non-functional requirements. So functional requirement is how it behaves. What is the use case of that particular thing that you are creating? For YouTube, it is going ahead and uploading the video, liking the video, commenting on the video, watching the video, or these kind of things. These are functional requirements. Okay, they will come from you as a PM. You will put the user stories, and that is how it is going to be possible. While there are some non-functional requirements, which is yes, the system should be able to go ahead and give the data between 1.5 seconds. There has to be availability. It has to be performant enough. Then customer data will be encrypted to level 5 encryption standard. This is security standards. Okay, so these are non-functional requirements which are not so obvious, but as an engineer, as a product manager, you always have to take care of them. Security, performance, availability, reliability, all of these things should be by default in the organization. And whatever system design that we have done, it is going to help you collect the non-functional requirements. Cool. So understood the difference between the non-functional and functional requirements, right? Cool. So now we'll
Yes.
go ahead. Yes. So now we'll go ahead and talk about YouTube system design. Okay, what could be like a high level understanding of how we can go ahead and how the YouTube would have worked or how it is working right now. Okay, so we'll go ahead and break down our conversation into 4 parts. First is articulate features or user stories. Second is about data modeling. Okay, we'll talk about so first point is important for you as a product manager to know that yes, these are the features that we need to build. Okay, second is data modeling, what the data schema at the backend should look like. We have discussed this in the initial sessions. Then important APIs that we have done in the last session, and then HLD for non-functional requirement that we have done today. Okay, so we are going to do all of these things so that it is a revision for everyone, and also we are going to understand how this thing actually works. Okay, so first thing is articulate features. So here we are only looking about 2 features. Although YouTube has like thousands of features out there, we are only talking about 2 features. The first feature is upload a video. Second feature is watch a video. So a user can come and they should be able to upload the video. And user should come, they should be able to go ahead and watch a video. Okay, now we have to create schema. So can anyone tell me what could be the schema or what could be the tables over here?
Maybe file type.
Okay, tell me the name of the table first.
Okay, so video could be the name of the table, or maybe video properties.
Login.
Video, okay.
Login.
Login is
Si-
might not be, but I'll write it. We'll correct it.
Size, name.
In video, we might have the size. We might also have the name of the video. Anything else?
Length of the
Format.
video.
URL of the video.
Yes, URL.
Description.
Date timestamp.
Description.
Yeah, timestamp.
Timestamp.
Who uploaded it?
Number of
Yes, now-
subscribers.
Yes. Now this will be user who has uploaded it. So now the user who has uploaded it. Okay, now we have a new thing. We have to understand, like we have to contain the context of it, right? So now this should be connected to a new table, which is known as users, where we will maintain a user ID and also other information about the user, which is their name, their email or something. And there, this will be user ID and will be contained, like gone ahead and connected to this particular table. Okay, user ID.
And
Anything
one-
else?
One flag here, is it created, updated,
Flag for what?
created, updated?
Status
Or
flag.
Because you also have the option of updating a video, like thumbnails or something, you can update there.
okay, we'll keep it simple and we'll just create it. It is like public. Or
Yeah,
it is
public and private also.
Yes, we will keep this particular flag.
Comments.
Comments. Now, how will you introduce comments?
Do we not have a video ID for which kind of identifies the video?
Yes,
and can
yes,
have
yes, yes, yes.
like,
Correct, correct. This is also
comments?
important. Video ID is also important. Yes. So how would you know whether it is a video?
Also, playlist ID be an important part because obviously
We are
could
not,
be-
yeah, we are not going to discuss about playlist right now because I have only explained two things, and maybe one is important because users should be able to create their account. That is also there because playlist will make it more complicated for you.
Okay.
Yes.
Video ID and comments.
Video ID is there. Okay. Now for comments, what we need to do?
In the video ID, there will be separate table for video ID in which we'll have comments, then
Yes,
the
yes, yes.
likes and all those things.
And user
Correct. So
ID.
we can have a comments table out there. So although it is like out of the scope, but I'll tell you how it works. So this is comment and the relationship is one video can have multiple comments. So we will have an ID of this particular table, which is comments table. Then we will write the comment. Then we will also mention who is the user who has made the comment, right? And we'll also contain the video ID and also like other information, meta information, such as the date or things like that.
Also now this can be mapped to other comments, right? Like one comment can have.
Yes, 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 correct. That you could go ahead and tell the maybe either you can add one more comment or maybe you can add some more things to this particular table as well. Although it is going to get more
Yeah,
complicated,
reactions.
but you can put maybe something known as level of comment, level 1, level 2, and then you can say if level is 2 or if level is not 0, then you will also write a comment ID as in for which comment was this a comment, like comment of comment. So that could get complicated, but let's keep it simple right now. Yeah, someone was telling something.
Yeah, Ankit, I was saying that instead of having this, we should have a reaction table with the ID and comments and like and
Yes,
dislike.
correct. So reaction table would also be there. Reaction will have the ID of the table, the person who has made the like, and also this is
Video ID.
actually video reaction, right? Because
Yes.
reaction could also be made on a comment, right? And here we would have the timestamp, but also the video ID. Okay, so now you understood, right? So we will go ahead and create tables. First table, so yes. Data modeling, okay. First we have the users table. Then we have the video table. Then we have the third thing was maybe the comments table. Okay, and then we have the reaction video table as well. Okay, this should be enough for our use case. Okay, so any questions so far, guys? Cool. So now tell me, what APIs are we going to build? What APIs are necessary in order to do all of this stuff? Tell me just the purpose of the API. We are going to map it into the request and everything.
Create video.
Upload video.
Yeah, upload video.
I think first would be authenticate or authorize the user. Could that be the first?
Yes, authentication could be one thing.
Create an account.
Yes, I would say authentication and create an account into one thing. These are
Comment.
mostly the part of authentication.
Comment.
Comment could be one thing. Yes, comment could be one thing. Add comment or yeah, so comment could also be add, delete, update, comment.
Viewing the video. I mean, based on the URL.
Yes. Which is get video, right? You
Mhm.
should be able to give the URL and that should happen. So I've also told you the verb with it. Okay, so let us talk about only 4 part: upload video, this, and this. Okay, so how the API is going to look like for, let us say, upload video. So what, let us say we make like a sample that like a sample API endpoint, which is /add video. Okay, or we can just say video and then we can put 4 things. Okay, if it is put, that means that we are trying to edit the video. If it says get, we are trying to get a video. If it says maybe the put, get, or what was that, post, we are trying to upload the video. Or we can say maybe delete, we are trying to delete the video. So you can contain all the 4 parts into one particular endpoint, or you can also make sure that you are creating other endpoints, such as one is you are talking about view the video, which is get. You can create another endpoint for post video. You can create another endpoint for maybe
Indeed.
editing the video or updating any information with the video. Okay, so you can do it both ways, and there are engineers who do it both ways as well. Okay, now but ideally what happens is that if you're talking about one resource, you should have one API so that which can add it and update everything out there. Okay, but this is also a practice that is preferred. Okay, you should understand the basics of it. Okay, so now this is an API. What is the request that we are going to send it? If we are looking to post a video, okay, so in the request, post video or upload a video, okay, the header so there would be a header and there would be a payload. Okay, so in the header would be, what all the things would be in header?
Authentication ID
Authorization.
and session ID like the previous one.
Yes, authentication. So we'll know that whether this person is like going ahead and uploading in the same video or not, whether they are eligible for creating the video or not.
Yeah.
Yes. Anything else?
Then some parameters would be there.
What kind of parameters?
And what type of video is it? No, that will come in payload.
Right. So now one thing more will come. Okay. So here
Yes,
when you are sending the payload, okay, this payload is actually not going to be standard JSON.
Yeah.
Okay, it is going to be an actual MP4 or MP5 or any kind of video out there. Okay, so this is known as multi-part.
Yeah. I was.
Okay. Yes, correct. So here in the header, initially we missed one thing, which is what is the type of data that you are sending here? Okay, it should be contained in the header. For the initial request that we have done, it should be JSON or it should be XML or any plain text data that you are sending in the forms. While in this case, it should be multi-part.
I mean, 80% of the time, I think it is application/JSON.
Yes, correct. Cool. So this is it. So now the server will understand, it will expect that yes, this particular type of file is going to come. Then the file will come to the server. It is going to make sure that yes, it is storing it somewhere. Okay, in the file system, it is storing the data. Okay, now after that, what will happen? Okay, so this is the user. They have gone ahead and uploaded the video. Okay, and when they have uploaded the video, user Facebook will, this particular person, YouTube will go ahead, they will accept the video through video add URL. Okay, it will send the multi-part type and the file would be sent. Okay, now what will happen is that on the backend, many things will happen. Okay, first of all, it will in the table or videos table. Okay, it will store this, it will create an ID. Okay, it will first go ahead and find a place, which is a file storage. Most common type of file storage is actually S3. Okay, which is a service offered by S3, which is known as simple secure storage or something. Simple secure, yeah, simple secure storage or something. I'll find out the name and tell you. So this is a storage, this is the service from Amazon, which is used for storing like bulky data, images and videos and all. Okay, so let us see that they have gone ahead and stored it over there. Okay, now when they store it, they are going to get a URL. in return from Amazon. That yes, at this place, this video is being stored. Okay, this URL would be here. Okay, ID would be generated and other things might be possible. Okay, now if there is one client, okay, they want to watch the video. Okay, and now this video was actually uploaded in maybe 8K resolution, and now this client is maybe sitting in the remote village of India and using a 3G connection. Do you think they should also be getting like the 8K image of it? Okay, they should ideally be getting maybe the 320 or 480 pixel version. Okay, so YouTube also have to make sense of all of these things. So what they will do is they will make sure that as soon as the video is uploaded, okay, they will put the video to processing. Okay, so one other layer will come. They will put the video into processing, and then the video would be converted into multiple formats such as 1080, some bigger resolution, lower resolution, so that it is also available. And then there would be another table, or maybe in the same table they will mention that yes, this is the resolution of the video. So same ID, different resolution could also be there. Same video ID, but different resolution would also be there. Okay, they will understand this and then send the data to there. And now in order to access this data, this person will again have an API. Okay, so now we have talked about uploading. We'll talk about getting video. Okay, so here maybe the URL is video watch, or for YouTube it is youtube.com/watch / video ID is equal to something. Okay, this is what YouTube follows. Okay, so what will happen is that when this is there, okay, along with this particular information, we will also have the context about the client. Okay, so YouTube will also know the server which is serving this request. They will also get from client that what is the device that this person is using. Is it a mobile device? Was it the resolution of the device? Okay, and then they will also understand what is the network type, or maybe what is the bandwidth that they are at right now. Okay, and based on this information will also be sent to this particular parameter, and based on this they are going to go ahead to this particular API, and based on this they are going to decide that yes, they will search for this particular video in the database. They will search for what is best for this particular resolution, and also apart from this, maybe it is possible that yes, user is coming from a very small mobile device and they not have a good connection. But before, over and above all of this, if user has selected that I want this particular resolution only, even if it does not load, then all of that information will supersede all of this. This logic will happen at the backend, and then it will send the data to them.
So Ankit, one question here. So all these things will be decided as soon as the user opens YouTube.
As soon as the user opens YouTube. Okay, if you are opening the YouTube for the first time, then it is going to happen there. If you are again opening the app again and again, maybe for example, if you have stopped the ad, you have killed the ad, then now you're opening the app again, then it has your data already stored in the cache or maybe the local storage of the app. So next time they do not have to capture the data, they already have it from your device.
So one more thing here. So let's say today I opened it in Bangalore. Okay. Tomorrow I am going to some remote part of India and opening there. So they are all.
Yes, correct. So I'll tell you, your device is always available. Your device is same. Okay, but network to anyways changes. So they will understand from that particular period of time. So if you go ahead and go to YouTube, right click on any video. Okay. So let us go to YouTube. And let me maybe click on this. And there is thing known as stats for nerds. Okay, there you will see whatever they have. They have your connection speed, they have your network speed. My connection speed is this much. This is the buffer health. So they are already getting all of this data in order to understand what to serve you.
Okay, can you right click again? I want to see where it comes.
Stat for nerds.
Oh, stat for nerds. Okay, I will have a look at it.
Okay. Yes. Cool.
Ankit, on the multi-part bit, so when you are actually uploading a video in the payload, you're actually putting the file, or is that like?
Yes, the actual file is there in the payload. The MP4 or any file that you have, that is actually going to be sent over the system out there.
So multi-part essentially is some file format which
type
is not
of data,
JSON
type
or
of
XML.
data, type of data. Yes, it is type of data
Which is not JSON or XML. Okay.
this is not JSON or XML. Yes, it's correct. So understand, in multi-part, you can even send JSON and XML. Okay, but that would not be the correct way, because multi-part contains everything.
Okay. And
Yeah.
we've also seen that in YouTube, I think they've done this where during the video also the quality sometimes goes, it becomes
Yes,
better,
yes.
and so
Correct. So I've told you.
are we
yeah,
saying that there are multiple
Yeah.
APIs getting called when I'm watching the video as well?
Yes, correct. So you look at this video. Okay, that is what I was showing you, that you go ahead, click on this. This is actually changing, right? If I go ahead and click the video, look at this. These things will keep on changing. So as your network is going up and down, they know, and they are going to adopt on the same.
So is there multiple APIs being kind of
One API is
in the
being
background
called
doing
one API is actually connected to your system. Okay, like
which is like
one
check
API from
system
the server.
capability
Yes,
or
yes.
something like that, which is
It
actually
it
doing
makes sure that it is always running. It is always connected to your system from their server to your system, also known as web sockets.
So
If
in that
there is
case,
one more
the
term you
first
should
part
know.
of the video. So in that case, the first part of the video, let's say, is 240 pixel, but the second part of the video where it has to actually
Yes,
will be
correct.
480
Even on the microsecond level,
Okay.
they will understand that you have started the video as a poor video. Okay, but you have not selected anything from there. Okay, so for example, right now my data is not very much correct. Okay, I'll go ahead and open this. Now I switch it from 3G to maybe my network connection, my 4G or 5G network connection. Then it will improve the quality.
Okay, got it.
Yeah. So all of this thing is working in real time. Cool. Yes. So now, and this is also like very simple, that if we go ahead and create all of this diagram, there is the client. Sorry. Yes. So there is the client. The client is going to go ahead and upload the video. Here, what will happen is that we will have one service, which will one application logic. Understand, there will always be like a load balancer above there. We are not just considering that to make the diagram more simple. Okay. Then the application logic, what we'll do is it will store this in the database. The tables we are going to use is the video table, and we are also going to use the particular table known as users, in order to make sure that the right user is loading it. Okay. And here, as soon as this is being done in parallel, it will also go ahead and put it in the processing queue. So if you guys have gone ahead and uploaded a video on YouTube, you will see that it takes like 10 to 15 minutes for a normal 1 hour video to process. It will upload the video. You will get the success in 2 minutes that yes, your video is uploaded, but it will put the video in processing so that it can get multiple parts of the video in different kind of optimization, different kind of resolutions out there. Okay. This will be sent to processing. Okay. And multiple other videos are in the processing. Okay. So this is known as a queue. User does not have to do anything with it. Okay. This processing is not going to hinder this. This is being uploaded, and then this is happening in the parallel. Okay, this is known as a queue, which is happening in parallel. Okay, so now this is going to be processed. Whenever it is done, it will again inform the application layer. So application layer will do two things. It will send you a notification that now your video is ready to be shared, and it will also go ahead and update the database that yes, for this particular video, we will create maybe one more table of video underscore types or different resolution. There we can mention this is the main ID of the video and these are the resolution that we have. And then whenever a user goes ahead, maybe client 2 will come, or the same client wants to watch the video, then they are going to go ahead and ask the application layer that I want to watch. So they will get the ID from there. What is the ID of the video, which is like stored on every URL. Okay. Then it will find it here. If it is into processing, if they do not have the right type, they will say that no, this is still processing. But if it is processed out there, they will go ahead and send the data back to this particular person. Okay, so this is a simple high level diagram of how YouTube works. I'm also going to again share like a other like note with you, where you can go ahead and understand how like the streaming part works. Okay, because understand in live streaming, that becomes more complicated. Okay, you cannot expect them to go ahead and store 8K video here and then parallelly go ahead and publish it to other kind of people out there. Similar, like millions of people out there, that contains like a different kind of ball game altogether. Okay, so now tell me everyone, on a scale of 1 to 5, your understanding of system design in YouTube before this session and after this session. Like before 4 and now 4 in this format.
Ankit, if you could repeat the video type bit where you're saying while it's processing,
Video type
how
as in?
does it get?
Okay,
How,
so I'll tell you.
what, if you elaborate the video type bit? As in,
Yes, so I'll
if
tell
it's
you. So
processing-
we have only talked about one table, which is video. This is the ID of the table. This is the URL of the table, and this is maybe time and other information. Okay, now we have created one more table because we want to have video in multiple formats. Okay, so now this is video types. This is the ID of the table. This is the video ID, and this is the type. Type as in it is like 1920 by 14, or you can tell it as resolution. Okay, so now what will happen is that parallelly, when the client has given the video to the server, okay, the application logic layer, it will first, without making the client wait, it will go ahead and store these things to their file system and also store a reference to it in the database. Okay, so it will store in the file system, and file system will give them a URL, so they will store it over there. That yes, this is the URL, this is the video, this is the description that this person has said. Now parallelly, they will go ahead and again start a new process. Okay, this process will be processing this video into and creating it into multiple parts. Once that is done, this will get updated that yes, this was the video ID number 1. This resolution is high resolution or 1920 by 1080, and it is going to publish more tables. Once it is done, it will again go to the data to the logic layer, and it will inform the client that yes, this has happened. Now you can go ahead and start sharing your video. Does that make sense?
So,
Vivek?
okay, so yeah, okay, it makes sense now. So when the API gets called, for example, the hypothetical API, which is view video, is getting called, it actually gives me the video type which is more suitable to my network. And when I click
Yes.
on settings and decide to select the quality, it
That will be
actually
different, yes.
goes into the video type database and then
Yes.
figures which is actually available, because some of the videos are actually only 240, 480, and 720, whereas some of them may only be 360 only.
Right,
that's
correct.
why
So
it does that.
whenever this
Got it.
processing is happening, they are going to understand if it is even possible with this video or not.
Okay, got it.
Cool. So they do not upscale videos; they mostly downscale videos. 8K videos are also going to be shown to you in 4K and HD and double HD. But yes, but upscaling they do not do right now so far. But that would also be possible because we have seen AIs which can go ahead and take a pixelated video and make it into a really high definition video. So that could also be down the line. Cool. So any other questions so far, guys? Any other question from anyone?
Wouldn't it create so much of a problem of storage, because they are actually creating so many versions of the same video, and then so many people are actually
when you are
uploading
earning
that and
35
then-
when you are earning $35 billion like a year in profits, that does not matter.
Well said.
Fair enough.
Yes, cool. Any other question from anyone?
Ankit, one question. So
Yes,
how
please.
frequently does it check the network on the power? I mean, the how frequent? Because it happens, I'm in Bangalore, like 5 minutes before it was good. Then again, I'm watching the video, then the network is low. So
Cool, cool,
should
cool.
it
So-
keep on checking every time?
Yes. So I'll tell you that there are two kinds of things. So now I'm throwing a new concept at you. Okay. So your device, your mobile, and the server. Okay. Whenever you are opening that website, whenever you are open this app, even at the background, they are always 24/7 connected. And this is happening because of a system known as WebSockets. Okay. So initially, like till 2005, 2010, the server has to ask them something. The client has to ask them something, the server, then only the server can respond. Okay, the server by themselves cannot go ahead and share the data without client going ahead and asking them something. Okay, or if server has to send, then they have to put a timer together. Okay, as in yes, after this period of time, yeah, I'm going to ask for this data. Okay, now because of WebSockets, it's a technology which makes sure that both of these things are connected to each other 24/7, unless you go ahead and kill your browser or kill that app out there or close that website. So the chat system, Slack, okay, it is possible because it works on WebSockets. So it keeps the connection always alive. So it is always watching for your bandwidth and any information that you might be having there.
So is it the same concept applied in this share market also?
Yes.
Because
All
there,
these are known as real-time applications or something. I think there is a name that is given to these kind of things out there.
okay.
And also Facebook in 2011-12, when they have created like this, and Yahoo Messenger when they have created this chat mechanism, it was very difficult for them because at that period of time WebSockets was not enabled. So what they did was, there was a server. Okay, there is a server and then there is a client. So for example, client number 1 and client number 2, they are chatting with each other on Yahoo Messenger. Okay, but what used to happen was, since it cannot go ahead and proactively, it cannot listen to what they are saying. So what it has to do is, after every 2 to 5 seconds, it is going to see if they have typed something or not. If they have typed something, then it will take it and send it to them. And similarly, it is going to listen maybe for 2 to 5 seconds. So it was very costly to build, and every time the system was going ahead and it was connected to so many clients out there. That was the problem of scaling. But now with WebSockets, with support of browsers and every kind of device out there, it is possible that the connection is always alive. Cool. So I think we are done. I think this was like a very important session. And yes, so what we'll do is, in the next session, which is going to happen, I'm not sure the time because Monday I have some commitment. So I'll inform you the next timings. And in the next session, we are going to discuss briefly about cloud, like what AWS is, what the story behind this, what are the important things that they offer. And then we'll walk into the explainers and how does the developer system ecosystem works and how you can make sure that you are able to work well with the developers. Okay. I think sockets or WebSocket, they also do the same, because there is only one technology that helps you do the same. Initially, there was a technology known as pushing and pulling or polling. This is, I think WebSocket is used by WhatsApp as well. Cool. So yes, Sriharsha, you want to ask something?
Yes, Ankit. So my question is with regards to a PM's responsibility around all this system design. Suppose you are a PM for an e-commerce platform or a video streaming platform that we've been talking about. So on a given week or a given month, you see your ratings are dipping, where users report that a specific web page or a certain channel is not, it could be any reason that the website isn't loading. So as a PM, what is the expectation in terms of a basic troubleshooting?
Okay, so understand, I would say that first of all, you should understand that yes, all of these things, how they work. Okay. And then you have to understand that yes, if it is a simple latency issue, you should go to the developer and ask them to find it out, because understand, these architecture are far different for different kind of companies. Okay. Yes, if you have some idea, if you can go ahead and look at the inspect element tool and find something, that is good, but that is not expected out of you. You should be able to understand that yes, if user is saying that yes, if how you can help the developer is that you can check this particular user has left the review, and your Google Play account or your iOS account is going to tell you where you have uploaded the app. It is going to tell you which device have they came from. So you can go ahead and give this information to the developer and let them find. So before this session, before all of these technology sessions, I've made it clear that use this information just as your general knowledge. You do not have to go into the territory of the developers out there, because it is not necessary. Understand, although you can go ahead and learn all of these things, but in your priority, this is not going to come. There are more like bigger fires for you to go ahead and extinguish.
Ankit, one more thing I want to ask. So how much knowledge of these things are required to apply for a technical PM role?
Okay, that depends from company to company. Okay, so if you are applying for an AWS, Amazon Web Services, as a technical PM role, then you are expected to know your shit. Okay, but if you are applying for maybe their e-commerce part, okay, or it depends from job description to job description. If you are there in a very technical company and they are calling you a technical product manager, understand your role is similar to an engineering manager. You have to understand tech as well. You have to understand business as well. You are mostly inclined toward the execution part. So understand the job description or talk to the HR. They are going to tell you the best answers. I have also seen people like someone who has, I think he has done BCA, no, not BCA, BSc or BA something. They have become like a technical product manager at Amazon. So depends from profile to profile.
One more thing, they would not ask us to code in interview.
No. That is most probably that is not true, that they are going to ask you for code. But understand, if in your resume or when you are talking to the person, you have told that I have gone ahead and I have also helped my team in coding. Now they will come to the board and let us show what you have done.
Okay.
So it depends on your conversation.
Okay.
So you guys should be able to lead the interview. Okay, so if you are telling someone that yes, I have gone ahead and helped them out, then they might go ahead and in order to validate how well you can go over there, they are going to ask you. But if you say that I have helped them in the business strategy, then you can always like go ahead and control the direction of your interview out there. Cool. So thank you, everyone.
Ankit, one more doubt. So,
Yes.
I think whenever users report a feedback, right, and along with that, we also see those log files. So, who exactly defines what goes into log files? And as a PM, can you initially troubleshoot those log files?
Yeah, so understand, never think of it as like a responsibility, like as a major responsibility of any other person. Okay, if you think you have seen it, like yes, one review has came and now you're not able to find who was the person. Okay, so then you will go to the developer and tell them that boss, theek hai, abhi tak we have missed this particular log layer. But now from there on, you should go ahead and make sure that it is defined. So it can come from both ends. Your engineer can define it by themselves if they have the wisdom. Otherwise, if you are facing a problem, you can tell them. So going ahead and creating like a good software product, it's a teamwork. So you always have to align. Cool. So thank you, everyone. I think we are done now. Cool. Thank you. Bye and take care.